Hello, it's Miss Oak about to teach you some fun facts about mixtures. Um, I wish I could see you guys, but I can't. Okay, so for this lesson, you're definitely going to need your textbook. Um, I sent pictures of the textbook pages to your parents' email, so if you don't have that ready, go ahead and pause this video and turn to page 72. This PowerPoint is going to be much shorter than our usual lessons, obviously, because I won't be able to take questions and we'll be able to read everything together in detail. Okay, so mixtures. Basically, two or more things that are mixed together. Okay, so for example, snack mix, trail mix. We have some pretzels here. What else do you see? Some delicious M&Ms and Chex Mix and those different types of crackers. So basically a mixture are two or more things that are mixed together, right? Just like this. The key point, however, is that each of these substances, so each of these snack pieces keep their own identity. So the pretzel tastes like a pretzel, it smells like a pretzel, it's a pretzel. The M&M tastes like an M&M, it smells like an M&M. It's different from the pretzel, right? Each snack keeps its own qualities, characteristics. Okay? Another example, nut mix. So we have cashews, almonds, peanuts. Each of these nuts, again, have their own taste and color, etc. So that is a mixture, right? And another key point is that each one of these mixture items can be separated from each other. I wish I had a real snack mix right now. Okay, now a mixture can change physically. So for example, here we have some delicious strawberries and some yummy ice cream. What would happen if we mixed both of these together in a blender? A very delicious strawberry milkshake. I wish we were drinking strawberry milkshakes right now. We have the strawberry milkshake. However, it's still a mixture because it didn't change into a totally different substance. You can still see the little pieces of strawberries in there, right? And we know that the reason it's so milky looking is because of the ice cream. So we still have the same features of the strawberry and the ice cream. It just tastes a little bit different. It's more delicious, right? So this is still a mixture. But it's a mixture where strawberries and ice cream went through a physical change. So physically it looks different. Can we agree? This strawberry looks different from this milkshake, and that ice cream looks different from this milkshake. But they're still the same properties. Okay, other examples of mixtures. Vegetable soup. Again, two or more things mixed together. However, you can still separately pick these out, correct? We got the carrots, the potatoes, what else do we have in here? The parsley, the corn. Each vegetable has its own property. And next we have the famous rapogi, right? Again, very delicious. However, we can still pick out each of the different ingredients with our hands or our chopsticks. We got the rice cake, the fish cake, the ramen noodles, just very delicious things. Each of them have their own qualities. It's a mixture. I think we're getting hungry, so let's switch gears. Now we got sand and shells and rocks. Again, each of these things can be picked out, correct? And each of them have their own properties. So this is a mixture. Now, it's important to remember that some mixtures separate. As you know, oil and water, perfect example, yes? If you mix oil and water together, eventually it will separate. And if you have ever bought this kind of orange juice, you know that sometimes in orange juice, the pulp, so the actual pieces of the orange, right? the pulp will usually separate from the water, the sugar water, as you can see in this picture. So it is possible for mixtures to separate. That's why when we have some juice boxes, it says on the label, please shake well before you drink it, right? Because otherwise it's just gonna taste like water. So those are mixtures. Snack mix, peanut mix, strawberry milkshake, vegetable soup, raboki, sand, rocks, orange juice. Now let's do some reading. So go ahead and you can pause this video here and go to the textbook, page 72. Okay. You can either just stop this video right here and read on your own. I know some of you prefer this. That's totally fine. If you want to read along with me, go ahead and keep playing the video. All right. Mixtures. Sometimes different substances combine without going through chemical changes. A mixture consists of two or more substances that are physically combined. Unlike the molecules in a compound, the particles of each substance in a mixture keep their identity. Think of a snack mix. A snack mix is a picture that could include pretzels, peanuts, and raisins. The pretzels, peanuts, and raisins did not change to other substances when they were added to the mixture. They each kept their own identities and properties. The amount of each substance in a mixture may vary. If your family likes lots of raisins, you can add more raisins to the snack mix. You could also add other substances such as crackers and candy pieces. Each substance in a mixture can be separated from the mixture. Since each substance keeps its properties, it may be identified and removed. You may like to pick all the peanuts from the snack mix and eat them first. The peanuts look and taste different from the pretzels and the raisins. The matter in a mixture may sometimes undergo a physical change. A physical change includes changes of physical properties, such as the state of matter, color, or texture. Strawberries and ice cream go through a physical change when they're blended to form a milkshake. Combining the strawberries and the ice cream does not form a new substance though, because you can still see the strawberries in the ice cream. In some mixtures, the individual substances are not spread evenly throughout the mixture as in the snack mix. Another example of this kind of mixture is granite. If you look closely at a piece of granite, you will see that several kinds of minerals have mixed to form it. However, the minerals are not mixed evenly throughout the granite. Each piece of granite may have a different mixture of minerals in it. So if you compare one piece of granite to another piece of granite, you can kind of see they don't look exactly alike. Just like in this picture here, that's an example of a granite, right? But not every piece of granite looks like that. It is easy to identify the substances in some mixtures as being evenly mixed or not. You can easily see that vegetable soup is not evenly mixed. Likewise, if you look at the sand on the beach, you can see a variety of rocks and shells in it. No two handfuls of sand have exactly the same substances in them. So if you go to the beach, relaxing on the beach, take a bunch of sand, and your brother takes another bunch of sand, will it be the same? No, because they are not evenly mixed. Some mixtures separate if they sit for a while. Orange juice, some liquid medicines, and paint are mixtures that separate. And these mixtures may have labels that say shake well before using. And shaking these mixtures combines the substances again. The shaving cream that many men use each morning, your dad might use it, it's right here. So the shaving cream is not evenly mixed. Shaving cream mixes a gas with a liquid to form a mixture called foam, like this right here. An aerosol is also a mixture of liquid and a gas. So we have aerosols like hairspray, right, and perfume. So in some aerosols, you may even be able to see the droplets of liquid. Some hairsprays come as aerosols. All right, so we got some really good examples here. Liquid medicine says shake well, foam, aerosol. So these are mixtures that are not evenly mixed, right? You might have to shake it. And we got the delicious snack mixes, etc. Awesome. So now that is it for science class today. There is no workbook page today, but we are going to be reviewing some of this tomorrow on Tuesday and do workbook pages. Awesome. All right, see you in reading class.